379, we're going to graph. So we know all of the parent functions of exponentials, and now we're going to be expected to know all of the parent functions of logarithmic graphs. Logarithmic graphs are the inverse of exponentials. So right now, one way that you could figure out the graph of y equals log base 4 of x is first graph y equals 4 to the x. And that graph we know goes through which 2 points? 0, 1, and 1, comma 4. And we know that it swoops up and has an asymptote at y equals 0. Every time I use the word swoop, I think of swoopo, which is, yeah, anyways. I don't know. And so to graph y equals log base 4 of x, we know that we're going to have the point 1, 0 and the point 4, comma 1. And what's going to happen to the asymptote? Instead of y equals 0, it becomes x equals 0. And your graph curves like that. Now, instead of always having to graph the exponential first, I think you're going to get to a time where you say, I know what a log graph looks like. And just like every exponential goes through 0, 1, what point is every logarithmic graph going to go through? 1, 0. And this one goes 1, comma the base. This one's going to go through the base, comma 1. And so you'll be able to say, I know how to graph every single base graph for logarithms, and we're going to do all the transformations with log graphs as well. Oof. Oof. So the intercepts of y equals log 4 to the x, well, we only have an x-intercept, which is at 1. There is no y-intercept because we have an asymptote at x equals 0. Is there an asymptote? Yes. The asymptote is at x equals 0. The domain, x is bigger than 0, and the range is everything. Do you notice that that's sort of a switch of what we had here? Here we had, for this one, the domain is everything, and the range is bigger than 0. And so same thing with domain and range when you're doing inverse, the x's and the y's switch. Do you still have space at the bottom of page 378? Okay, so at the bottom of page 378, we are going to graph this. That is an L. So you've never seen ln before. ln it's the natural log. The ln button on your calculator is right underneath the log button. When you have the log button, if I got you to graph this, what's the base? 10. And it's not written. It's sort of just, it's a special log. This one's called the common log. It happens often enough that we don't write the 10. The natural log also happens often enough that we don't write the base. Any guesses what the base might have been right here? No? No? Think special. Oh, that's pretty special, but not special enough. Yes. The base is e. So the natural log of x is exactly the same as writing log with the base e of x. E is a number. It's 2.718281828. Yeah, that's what it is. 2.7, though, if you have that basically memorized, that's good. So now to graph y equals the natural log of x, it's the same shape as all log graphs. What point is it going to go through? 1, 0. Definitely is going to go through 1, 0. And what's the second point going to be? E, comma 1. And there's going to be an asymptote at x equals 0. Yes?
So what is the point of, like, why can't you just write log ex? Like, why do you have to have another?
Why do you have to have a special? So when something happens often enough that it becomes special, mathematicians tend to get lazy. And they don't want to write extra stuff. So I know this is only 2 extra letters, but it happens often enough that it makes sense to change it to something even shorter. And the reason why it's ln stands for natural log, but I think it comes from French. Logarithm naturel. Something like that. Something fancy. Okay? Right, we've done things like this before. Why don't mathematicians write this like this? They don't like to write the brackets. So what do they do? Oh, let's make up something new. Let's put the squared there, then we'll know. So when something happens often enough that you want to create a symbol to write it shorter, like you could write every time square root of 5, or you could just do this weird symbol, which is a lot less work. Okay, questions for graphing practice 10 and 11.